Hello everyone. In today's video, we are going to be talking about one of the most fundamental concepts of computer science, which is binary numbers and how to add binary numbers. So first, let's talk about binary numbers. So what are binary numbers? Binary numbers are basically digits which are represented by either 0 or 1, and the binary numbers are expressed in the base 2 numeral system. So for example, if there's a number 101 base 2, this is how we know it's a binary number and not a decimal number of 101. That's how we can differentiate. But why is it only 0 and 1? Why is it not 3, 4, 5, 2? You must be wondering. So the zeros and ones in a binary represent the off and on respectively in a circuit. So in a transistor, a 0 represents no flow of electricity and 1 represents electricity being allowed to flow. So in this way, numbers are represented physically inside the computing device, which allows to carry out calculations. So basically, if it's a circuit is electricity is flowing throughout the circuit, it is 1, and if the electricity is not flowing throughout the circuit, it is 0. So how do we convert from decimal to binary? You must. So if you're converting from decimal to binary, suppose the 17, just keep dividing the number by 2 until you reach 0. Then you take the remainder from each time you divide the number and place them from right to left. That's the number in binary. So let's do an example. So we have 70 over here, divided by 2, you get 35. Zeros are remainders, so we just write that here. You divide 35 by 2, we get 17. Zeros are 1 is a remainder, we write that here. So I know you must be wondering that 35 divided by 2 is 17.5, but in this case we don't want a decimal number, so we just take 17 divided into 2 is 34, and there's one remainder, so that's why this will be the remainder column, and we just write the quotient 17 over there. Then 17 divided by 2 is 8, 1 is the remainder. 8 divided by 2 is 4, 0 is the remainder. And then 4 divided by 2 is 2, 0 is the remainder. 2 divided by 2 is 1, 0 is the remainder. And then 2 divided by 1 is 0, and 1 is the remainder. Okay, so you can see we have got a couple of remainder digits over here. So now what we do is we just place them from top to bottom, right to left. So it will be a binary number will be 0, 1, 1, 0, 0, 0, 1. Okay, so we can just write binary number is 0, 1, 1, 0, 0, 0, 1. But this is not the final answer. Memory in computer is stored in an 8-bit format, so the binary number will have to contain 8 digits. And as we can see in the answer we got, it's only 7 digits. So to make sure it's 8 digits, we just add 0 in the empty space before the number, because it won't affect the number and it won't change its value. If the number, supposing our answer has 9 digits, then we'll add 7 zeros before the number. This won't affect the number's value, but this is how it's stored in the computer, and this is how we represent it. So now that we know what binary numbers are, let's learn how to add these numbers. So while adding binary numbers, there are 4 fundamental rules that all of us will have to remember. These 4 rules are, these 4 rules are 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, and 1 plus 1 is equal to 1, 0, with the 1 being carried over to the tens place. So if you know these 4 rules, you can carry out any calculation very easily. So for example, if you have 1 0 1 1 plus 1 0 0 1. First, let me talk a bit about the rules. Why these rules are important to remember, because these are the only four outcomes that are possible out of, because there are only two digits we have to remember. So these are the only four possible outcomes, and these four possible outcomes have these answers. So you just have to remember them. Okay, now 1 plus 1, as we learned, is then 1 0 with the 1 being carried over. So we write 0 over here and 1 carried over. 1 plus 0 is 1, and 1 plus 1 again is 0 with the 1 being carried over. 1 plus 0 is 1, and 1 plus 0 is 1, so we write 1 here. And 1 plus 1 is 0 with the 1 being carried over here, we get 1. So final answer for this will be 1 0 1 0 0. But again, we need to represent it it needs to have 8 digits, because computer stores numbers in an 8-bit format. So we will just add 3 zeros before number. So final answer will be 0001 0100. Let's try another example. So what if we have 1111 plus 1111? So 1 plus 1 is 0, 1 carried over. So 1 plus 1 is 10 with 1 being carried over, but there's another 1. So in a case where you have 3 ones, you check. So if it's 3 ones, if it's an odd number of ones, you will put a 1 away, you'll write a 1 down and carry the other 1 over. And so like you will have 3 maximum ones. And if it's like, if you have, what I suggest people to do, if a sum is like 1 1 plus 1 1 plus 1 1 plus 1 1, I suggest people to first add these two, then add these two, and then add the final answer of these two. That just makes it easier, I believe, and it's less confusing. That's what I suggest people to carry out. Okay, so back to our original sum. We have, yeah, so then 1 gets carried over. So 1 plus 1 is again 1 0 1 with the 1 being carried over, but there's another 1, so it'll be 1 in the denominator and 1 being carried over to the other place. And then 1 plus 1 is again 10, but there's another 1, so there'll be 1 at the bottom and 1 being carried over. Then over here it will come. So our final answer will be 4 ones and a 0. But again, we need to make sure there are 8 digits, so we'll add 3 zeros before the number. Final answer will be 0001 1110. So I hope you learned like what are exactly binary numbers, how to convert from decimal to binary, and also how to add binary numbers. If you want to look out for how to convert from binary to hexadecimal, or from octal to hexadecimal, hexadecimal to octal, all of that I'll be covering in a future video, as well as subtraction of binary numbers. So stay tuned for that. Please hit the subscribe button below, and please like the video as well. If you have any doubts, put it in the comment section below. I will try to answer them. Thank you.